Hello, everybody, and welcome to this deep learning crash course. And today we are going to be starting with the crash course. And my name is Sadesh Thakur, and I'm going to be helping you throughout this journey. And this is a crash course, which means it is expected that you know some of the basics. But without a further ado, let's get started. So, here we are going to look over these 8 topics in this crash course. First one, with starting with a very general introduction of deep learning, followed by a quick review of CNNs, and then we would be looking into PyTorch as a framework and Pytorch-Lightning. Then we would be looking into medical imaging and medical image segmentation. Again, this crash course is mainly based for people who are more into research rather than people who are looking for development of applications and production based development. That's not for this course is not for those people. So yeah, then we'll be following it with a how to tackle a project, like how a general idea can be transformed into this research based project and can lead into papers and people using it all over the world. Then we would be looking at a very interesting piece of project, and I would be walking you through the entire journey of that project, starting from just gathering the data to all the other things. Then I would be following it up by a few tips and tricks that I have picked up over the years in deep learning, which have been consistently giving me results positively, and which is going to be helping over this journey. And then I would be talking a little bit about the deployment of the project, but again, depending upon the success of the series, it would be done on that basis. So, just getting started, the quick tour of deep learning would include introduction to machine learning and neural networks, and what changed back in 2012 when compute blew up like crazy and we got deep neural networks working pretty fast. Now, so machine learning can be diversified into supervised learning, unsupervised learning, and reinforcement learning. So, supervised learning is where you have a data that is labeled to something else. So, like for example, you look at a picture of a cow and you have a label named as cow to it, and that's how you know that that picture is a cow. So this is called as supervised learning, in which we have the availability of this verification of what the image is. And then comes unsupervised learning, in which we have, like, let's say a bunch of pictures, but there's no label as to what belongs to which class. And that's like a really hard problem because gathering pictures is easy, annotating every single one of them is the hard thing. Then we would be following it up with reinforcement learning. And here the environment provides us with particular feedbacks as to if we are doing good or not, as you can see in the GIF over here. Now, moving forward, we are going to show a basic introduction to neural networks. And basically, neural networks have been with us since the 1980s. It's just that they weren't super popular because the amount of computation that they would be using up would be terrible to do on a CPU. Like, basically, imagine CPUs back then were a few megahertz, like less than 500 to 200 megahertz, and these couldn't ever handle the amount of compute that we were trying to do. So then we came up with GPUs, and we got to this amazing affair of having these neural networks run very fast. And basically, neural networks, the back propagation algorithms is what usually makes the neural networks work. So that's a very expensive task, and that's why when people buy these GPUs, it's just for that one particular task. Now, moving forward, what happened was back in 2012 when Alex Krzyzewski and his partners trained a neural network that could, classify ImageNet. That is a problem of classifying a million images. That's when neural networks actually blew up. And when we say about what happens when neural networks are all about compute, it's majorly because the solution to solving any problem when it comes to neural network is most of the time just throwing a lot of compute at it. And that's about it. one of the biggest examples that recently has come to light is GPT-3. It's a 175 billion parameter neural network, and the cost of training GPT-3 was around $500,000. And though that does not include the cost of the GPUs, no, that's just the cost of electricity and nothing else. So that's what we are going to we are going to be looking into as we move forward. Now, a quick review of CNNs. This would include general introduction of how convolutional neural networks work, followed by image classification and image segmentation. So, a general introduction to CNN would be a convolutional filter that is moved constantly over a given image. So as you can see in the bottom right corner over here, we have this GIF which shows how the convolution operation happens and how these feature maps are created, which in turn help in generating an output volume. So that's how convolutional neural networks work. Again, this is a very rough overview of them, and if you want to learn more about the beauties of convolutional neural networks, please feel free to go to CS231N by Stanford University on YouTube, in which Justin Johnson, Professor Fei-Fei Li, and Andrej Karpathy have developed this beautiful course and explaining all the intricacies of CNNs. I personally have looked over that course 5 times in the past 5 years. So like that's once every year. And that's because it keeps my mind fresh about these very innate topics. Moving forward, image classification. As I have previously mentioned, looking at a picture, we have to classify which class does it belong to. For example, we look at a picture of a container ship, we would want to tell that it's a container ship. Maybe it could be a lifeboat, but it could definitely be a container ship, and that's what we want. So for example, you're looking at a dense neural network which is classifying the handwritten digits of MNIST into these 10 different classes of 0 to 9 digits. So it's an example of image classification. Moving forward, image segmentation. What image segmentation means is every single pixel in the image should be annotated or should be classified to a particular class. Now, obviously, this could be a difficult problem, but as you can see, it's not going to be simple moving forward when we check about how these pixels can differentiate based on image quality and a lot of other factors. But again, we are not going to discuss about those, but what image segmentation is, and in general, as you can see, every single pixel is annotated like a person, a pillar, a road, etc. Now, again, thank you all for coming here, and again, this is a quiz question. Please feel free to go into the comment section below, and we would be discussing a solution of this next time. Again, please feel free to fill up the comment section with all your queries, and I would be probably answering a lot of them. If you like this video, please make sure to show the video some love by clicking the like button, share the video to those people who could actually benefit from it, and subscribe if you haven't already. And let me know in the comment section below the topics that you would like me to cover. And if you really enjoy this content, please feel free to support me on Patreon, as this would keep helping me growing and adding more content further on. Until then, stay awesome.